Hello friends, thank you so much for your love and support. We have received a lot of message and some of you have asked how you can support the work we are doing. So we are creating exclusive content just for our supporter. You can access this special content by supporting us through the link in the description or email. Starting from 1st of June, we will be focusing mainly on CKA preparation videos in both English and Hindi so that everyone can learn comfortably for our supporter. We are also sharing helpful content on YouTube, so don't forget to check it out and stay connected. So our topic is resource request and limit in Kubernetes for today. So let's get started. Today's topic is request and limits. MITS limits. What are request and limit? Request. The words itself says how much you want. Could you please give me a glass of water? And one glass of water is your request. But limit. It's don't cross your limit. वरना थप्पड़ पड़ेगा. Don't cross your limit. Means if you cross your limit, whatever the consequence, you are responsible for that only. Okay. In terms of Kubernetes, it's in memory and CPU. So 1 means you can say 1000 M and memory is represented in MI and GI. Okay, so request means minimum amount of resource it guarantees. Minimum amount of resource, and this is very important, guaranteed. And limit, these are both are plurals, so keep it in mind. It's a maximum won't be tolerated amount of resources it can use. So generally this is the main thing. We'll dig into detail. So let's say a node capacity CPU is 1, or you can say 1000 M, and memory is 2 GI. Okay, suppose pod A request 500 M and 500 MI, pod B request 500 M and 500 MI. It's 512 I say, so it could be best. Right, so pod C, just forget everything that overhead or whatever, just for understanding purpose. If I request 100 I'm only here, but this is 500, this is 100, it already occupied all things, so this pod will goes in pending state, not because of memory but because of CPU. Scheduler only look for request, so scheduler only look for the request. Okay, so this request fulfill, this request fulfill, but this request is pending because nothing left for C. Okay, means if you have 4 bread, if you have 8 bread, 4 is occupied by mummy, 4 is occupied by papa, then nothing is left for you. It's like that one. So now you have to adjust this request, so you will adjust it like 300 or 100. Now it's 700, it will be this pending state pod will come or may need a restart. So if CPU exceed limit, what happen? In memory it's different, in CPU is different. If for memory suppose request is 100 for CPU I'll say request is 1 GI and limit is request is 1 GI and limit is 1.5 GI. If this goes, if beyond this, so you can say it's a throttling effect, means slow and unexpected behavior. If memory, like say it's 100 memory and it's 150 is limits. If it is goes beyond that, then container killed, and you will see OOM. Sometimes you see this OOM is known as out of memory. Another thing came into the picture, overhead. For CPU, it's approximately 5 to 15%. It can vary from company to company, but in generalized way, for memory, it's 15% to 20%. We can keep both 10% also, 15% also. If it is not mentioned, it's your call how much overhead you have to take for work to done. Now one more question is that there are if there is a deployment, and in deployment there is a main container and init container. So request, if you define equal request for both equal, then it's okay because it will not add up. In container will do something and then main container will work. But for a sidecar container, means there are 2 container or multi-container, both resource will add. Suppose here only if you define here, then at last 100 M is utilized, which means it's a request fulfilled. But here if in multi-container, container 1, container 2, container 3, all will be add up, means here 100M, here 100M, here 100M, then all will add up, and here 300M will be the requirement. Init container run one by one before the main container start. During init phase, only init container resource are utilized. Once init finishes, then this main container resources. So means for init container means both, whichever is higher, scheduler consider that. Okay, for main container, this all add up. For CPU and this all add up. So keep it in mind, for init container and multi-container scenarios will be different. Most people get confused in the request. It's a minimum guaranteed, and when it matters, and what it does. Minimum guaranteed and its requirement during scheduling, and limits its maximum uses allowed, and it's a during runtime execution. It's a static reservation. Scheduler uses a user request to decide which node has enough free uses CPU or memory to run the pod. It's guaranteed. Okay, and this limit, container can't go beyond the limit. This is enforced by C group. This is maximum container can use. Means if node has 2 GI available, but still for pod you can define GI, 3 GI, because it matters for the runtime after execution. Means maximum, that because this is maximum, it can go to 2 GI for the sake of understanding. But if the request is 3 GI, then pod will be in pending state. Demo will do tomorrow. Thank you for your love and support. Stay tuned and connected.